Hello, everyone. I'm Chetan from Navi Technologies. I'm working as a lead software engineer. I'm very excited and happy to be part of the Distributed SQL Summit. Navi is a financial company founded in 2018 by Sachin Bansal. Our mission is to democratize financial products and services that are simple, affordable, and accessible, being a customer-centric and technology-first organization. Navi provides a suite of financial products such as cash loans, home loans, which are very competitive in the market, Navi mutual funds, which has the lowest expense ratio, health insurance, digital gold, and our newest offering, Navi UPI. UPI is Unified Payments Interface, which provides seamless, easy, and fast money transfer. Navi, being a technology-first company, makes use of database as its core fulcrum. I will be now going over some of the challenges and the need for a new SQL. Our ever-growing user base demands for a database solution that can handle tens of thousands of QPS. We required a database that supports sharding of our data across multiple clusters. We at Navi have built our in-house partitioning sharding solution over the years, but have faced significant operational overheads, such as secondary index creation issues, inconsistency of those secondary indexes. We have seen challenges with real-time data delivery for our analytical and complex pipelining processes. We wanted a solution which is both Postgres compatible and helps us reduce cost as we scale. I will now talk about some of the inherent challenges that we faced with our persistent layer. So we see that during a spiky traffic, our latencies would spike up. We would see that our I/O latencies on a disk storage would increase. I would like to recounter a use case where once when we tried to delete and recreate an index for one of our services, we saw that the database queries started to pile up. At a point in time, the CPU utilization and the memory utilization of the database went up to 100%. Now, in order to mitigate, we tried first to reboot the database instance. Post the reboot, we did not see any improvement. Still, the latencies were high, and the database quickly went up to 100%. We then tried to upgrade the database to a much larger instance type. Even after doing so, we saw that there was no improvement in the latencies. As a last resort, we brought down the service, terminated all the connections. We then rebooted the database. After we analyzed, we saw that the indexes was partially created. As a result, what was happening was that all the queries were doing a full table scan, which resulted in this CPU spike. This triggered a moment that we had to look for a database that can help us solve all our index contention issues at large scale. Also, we have seen that during maintenance and database upgrades, we had to take a downtime of up to 60 minutes in order to be able to be operational. With UPI coming into the mix, it is very paramount for us that we scale throughout the day and 365 days a year. So we started exploring multiple database options available to us. We listed down some of the key decision factors that was paramount for us. We wanted a database that could handle real-time demands with low latency reads, and high throughput writes. Having burnt ourselves already with a manual sharding strategy, we wanted a database that had the built-in mechanism to efficiently distribute the data across clusters without we having to manually intervene. We also wanted first-class support for a real-time data delivery in order to meet our real-time downstream analytical needs and take care of a complex event processing pipelines for customer experience use cases. All of this, we also wanted a solution which helps us in supporting both our SQL and NoSQL workload. We wanted the solution to be open source and cloud native so that we don't have a vendor lock-in. We also wanted the service to be managed and overall help us reduce our cost as we scale. Yugabyte emerged as one of the ideal choices that would meet most of our key decision factors. Yugabyte's horizontal scaling capability of auto sharding and auto rebalancing allowed us to seamlessly scale our database up or down to meet the fluctuating demands. All of this with consistent latencies and steady throughput. We wanted to have a rolling restart and upgrade such that we could avoid any application downtime. Yugabyte's fast failover helped us with this. We were able to enhance user experience even during maintenance periods and upgrades. Before we could take Yugabyte to production, we wanted to perform a thorough performance testing and stress testing. We were able to achieve a sustained throughput of 2000 TPS with a 3-node 8 vCPU cluster for our current workload. We also, during the performance testing, tried to add nodes on runtime, remove nodes on runtime, and we tried to bring down one of the EC2 instances to replicate the failover scenario. We were able to see consistent throughput with zero downtime. We also observed that Yugabyte has been cost effective. During a performance testing, we were able to reduce our cost by up to 40% compared to our vertical scaling of our existing PostgreSQL nodes. This was significant as we scale going forward. Yugabyte supports Postgres compatible and Cassandra compatible APIs. This helped minimize developer onboarding time as they did not have to go through a full circle to learn completely a new system. This also helped us in not having to re-architect a lot of our code bases, which were already running the Postgres compatible APIs. Yugabyte also supported auto load balancing and managing our connections. So in a traditional PostgreSQL instance, there's a single instance which takes care of all the connection management. In a distributed SQL, since there are multiple nodes, the application has to know to a way to connect to all of these instances. One of the ways is to add an external load balancer, but that comes up with its own maintenance, management, and headache. Yugabyte provides a smart client driver that allows our application to connect to any of these distributed SQL nodes without having to maintain an external load balancer. The smart driver is both cluster aware and topologically aware. This helped us in scaling our services up or down without having to worry about the connection management. The connections would automatically scale as we add nodes, and would descale as we remove them. Yugabyte has inbuilt security support. Being in the payments domain, it is paramount for us to have encryption not only during rest, but also during transit. Yugabyte provides both encryptions at rest and in transit using custom keys or inbuilt provided keys. They also have row-level security, have great audit controls that can help us in mitigating any of the security risks and challenges and comply with any of the regulatory concerns. So Yugabyte that Navi currently uses is the managed Yugabyte type, which is basically Yugabyte as a Yugabyte database as a service. Currently, CDC support for Yugabyte managed is not there, but Yugabyte has promised to provide this to us. Also, most of our services currently use the reactive paradigm, and Yugabyte has promised us R2DBC Postgres Smart Driver support. We also have a need where for our live transactions, we would like to clean up our database with all the older records, which are only required for auditing and historical view. Yugabyte has promised support for automated PG Partman and PG cron, which can help us clean up and compact a database regularly without having to manually intervene. So currently, the way we do it is through partitioning and then deleting those partitions. But with automated PG Partman, we would not have to manually use the same. Yugabyte has also promised support for fine-grained metrics on the Yugabyte Managed portal, which can help us provide P50, P99, P99 metrics, and also push metrics from the Yugabyte Managed to Navi's Prometheus server. Overall, we have had a great experience using Yugabyte. Thank you. I'm open for questions. Navi is up for hiring. Navi is hiring for various engineering roles in the Android iOS space. We are also hiring for senior SDs and engineering manager roles. Please reach out to me on LinkedIn or to my email, chetan.k@navi.com. Thank you. And it is great being a part of the Distributed SQL Summit.